No, sir.
Oh, we'll get started. So I hope everybody will use the mirror formula, the magnification, all those things, right? So what is the formula? What is the expression for mirror formula? So if I ask you to give a definition for mirror formula, how would you define it? So it is some mathematical expression, right? It is a mathematical expression which gives a relation between what all parameters? Between the image distance, object distance, and the focal length. So 1 by v plus 1 by u is equal to 1 by f, or this can also be written as 2 divided by r. Why did I write it like this? Because f is equal to r divided by 2. I hope everybody knows this, right? So sometimes what they will do in the question is, instead of giving you the focal length, they'll give you the radius of curvature. At that time, you should not think on how to calculate the image distance or anything. It is just 2 by r that you need to use. Similarly, what is the formula for, what is the basic definition of magnification? Anybody? So how do you define magnification? If I ask you to give a definition to it.
So the ratio of height of image to the height of object.
Yes.
Increase or decrease in the image size.
Okay, that is a general way of saying. Increase and decrease, generally it speaks about the efficiency. Last year, I hope you guys would have read the word efficiency, right? So what does efficiency mean? It means output by input. So what is the main objective of a mirror? It is, the objective of a mirror is to show the reflected image of a particular object, right? So the reflected image might be in a bigger size compared to the object. The image might be smaller than the object size, or it might be equal to the size of the image, size of the object, right? So the property of the mirror, whether it can magnify the object and show or diminish an object and show, is what is called as magnification. If you have to give a proper definition to it, it is a ratio of whom? It is a ratio of height of the image, because image is the output, to the height of the object, right? So magnification is defined like this. It is hi divided by h naught, all right? The same height of the object and height of the image can be written in terms of image distance and object distance. How do you write it? M is equal to
Minus v by u.
You write it as minus v by u. The minus is minus is the indication that there is a magnification of a mirror. So minus is derived from the formula. Though you don't have the derivation, we need not worry about it. While you're applying the formula, you need to take this minus sign into consideration along with the regular sign convention. Okay, have this point in your mind. Is that clear, guys?
Yes, sir.
Yeah. Now I have certain questions. I say the value of magnification of an image is equal to 1. Okay. So I'll put a question like this. There is an object placed in front of a concave mirror whose magnification is 1. Then magnification is, I'm talking about the magnitude. I'm not worried about negative sign or positive sign. Whose magnitude means positive value. Whose magnitude is 1. Identify the location of the object and the image.
At C.
At C. How do you know
the
that?
Center of curvature.
Yeah.
Because
so
at the center of curvature, there is this image formed in the same size. When the magnification is equal to 1, it's the same size.
Exactly. So image distance will be equal to object distance. So the other way of finding it out is, suppose you don't know the ray diagram, then how can you write minus v by u is equal to 1? So v is equal to u. When is it? V is equal to minus u. When is it possible? Only when the object is at center of curvature. Right. Now I give a question like this. Next is, there is an object placed in front of a concave mirror whose magnification is less than 1. Where is the object placed?
At infinity and or beyond C.
Between?
Infinity and beyond C.
Infinity and C. You can just say beyond C, that's it.
Between beyond C.
It's just beyond C. So how do we know that? Because when the object is far away, the image will be small. Magnification, the final image will be smaller in size compared to the bigger image. So compared to the object. So v divided by u is less than 1, which implies the image distance is less than the object distance. Right? That's right. Similarly, if I put the same question, an object is placed in front of a convex mirror. An object is placed in front of a convex mirror and its magnification is less than 1. Identify the location of the object.
Anywhere. It can be placed anywhere.
Anywhere in front of the
Mirror.
right. Wherever you place it, what is the nature of a convex mirror? It will always form a diminished image. Right. So these are all the types of questions that they can question ask. So let's do a problem. From the problem, I want to explain certain more important points, like how they can actually take an assertion reason based question. I'm sure that everybody knows to solve a problem, right? But I want to give a different perspective of you thinking about it. So let's try to solve this. So there is a convex mirror for rear view on automobile, which has a radius of curvature as 3 meters. Now the question is, so let's try to dissect this. So radius of curvature is 3 meters. With respect to a convex mirror, is the radius of curvature positive or negative?
Convex is always positive.
Positive, because the radius of curvature is always on the right hand side. So I told you one important point. What is it? Whenever you consider the object should always be considered on the left hand side. Similarly, the reflecting surface should always face the left hand side. So R is equal to plus 3 meters. Next, if the bus is located at 5 meter distance from the mirror, so U is equal to how much?
Minus 5 meters.
Very good. So minus 5 meters from the mirror. Find the position, nature, and size of the image. So these are all the questions. So position means V is equal to what? Nature means they're asking whether it is magnified or diminished. The next is size of the image means what is the height of the object. Height of the image that they're asking. So V, U, and R. What is going to be the relation? 1 by V plus 1 by U is equal to, can I write plus 2 divided by R? No. So whenever you are applying the formula, you need to ensure that you apply sign convention to all the known parameters. For unknown parameters, you should not apply the sign convention. So here, what is unknown? V is unknown. So you should not apply sign convention. So 1 by V plus 1 by U is how much? It is minus 5 is equal to 2 divided by R is plus 3. See, I have a question. Okay. Even before you solve this question, can you tell me what is going to be the sign of V that we are going to get? Will the sign of B be positive or negative? So you are saying that B is going to be negative. So negative means where is the object image formed? It is formed on the same side as that of the object. So with respect to a mirror, if the object and the image are on the same side, does it indicate a real image or a virtual image?
Virtual.
It is virtual. But what does a convex mirror form? Sorry. When the object and the image are on the same side, you need to say they are real, they are virtual with respect to a mirror.
No, they're real.
They're real, right?
Yeah, they're real because it's the same side.
Yeah. Then convex mirror, what should be the answer? Final value of V? Should it be positive or negative?
Negative.
Negative. See, U is on the left hand side, no?
V is also on the left hand side, right?
V is on the left. See, that V is on the left hand side, then convex mirror will form a real image. Is the ray in the ray diagram that is given? Is there a place where convex mirror is forming a real image? Convex mirror by default always forms a virtual image. So even before you solve this problem, you should know that your answer of B will be, your V will be having a positive sign. So that is what I wanted to check. Okay, if at all you have a confusion, guys, please make a note of it. With respect to a mirror, write it down. With respect to a mirror, if the image and the object are on the same side, then the image is real in nature. Whereas if the object and image are on the other side, it is a virtual image. You guys make a note of it. Yes. I hope it is clear, right? So, okay, from here you can calculate B. It comes out to be 7.5 divided by 6.5. That is nothing but 14 divided by 13. Whatever is the answer, you can make a note of it. It is 1.15 meter at the back of the mirror. Now, what about the magnification? The formula for magnification is minus V by U. So it is minus of, what is the value of V, guys? It is plus. So plus 14 by 13. And how much is U? U is minus 5. So whatever is the answer you are going to get. Now tell me logically, should your answer be less than 1 or greater than 1? Even before you try solving it.
Less than 1.
It should be less than 1 because it is a convex mirror. Convex mirror always forms a diminished image. One more important point to be noted. If the magnification of a mirror is a positive value, please make a note. If the magnification of a mirror is a positive value, then the image formed is always virtual. If the image formed due to a convex, if the magnification of a mirror is positive value, then the image formed is always virtual in nature. Secondly, I would have told you virtual images are always erect. Okay, but with the positive sign, will I be able to tell whether it is a diminished image or a magnified image? The positive sign, will I be able to tell whether it is diminished or magnified?
No, sir.
Answer is no, because for me to tell whether it is diminished or magnified, what do I need?
The numerical. If it's more than 1,
exactly. You need the value of it. You need the value of magnification. That will tell whether it is a diminished or a magnified image. Okay. See, these are all the types of questions they can frame for 1 mark. So please be careful with all these points. I'm sure you know how to solve problems, but these are all the minor points you would have not observed. So ensure you're clear. Am I clear till this point? No confusion, right?
No, sir.
Guys, everyone, shall I proceed?
Yes, sir.
Shall I? Good. Now, let's do another problem. So there is an object. One more important point. Okay. So what is the other name for convex mirror?
Diverging mirror.
It's called a diverging mirror. Why is it called a diverging mirror? Because the reflected rays get diverged away from each other. Okay. Similarly, an object 4 centimeter in size. So what have they given? H.
That it's magnified.
So height of the object is 4 centimeter. So height of the object by default is always positive. See, these are all the things that are by default positive and negative. U by default is negative, whether it is a concave or a convex mirror. Height of the object by default is positive, whether it is a concave or a convex mirror. Okay, so height of the object is plus 4, is placed at 25 centimeter in front of a concave mirror. The other name for concave is convergent, because the rays get converged at a particular point in front of a concave mirror. So U, what should I take? By default, negative. And whose focal length is 15 centimeter. Focal length of a concave lens, is it positive or negative?
Negative.
Negative. Right. At what distance from the mirror should a screen be placed? See, what is the meaning of this point? At what distance from the mirror should a screen be placed? What will a screen do? The screen will capture the image. So indirectly, what are they asking? They're asking what is the image distance in order to obtain a sharp image in the sense a clear image of the object. Find the nature and size of the image. It's again simple. 1 by V plus 1 by U is equal to 1 by F. So 1 by V, you don't know the sign, plus 1 by U is minus 25 is equal to 1 by F is minus 15. Once you calculate this, you will get the value of V as. See, Now tell me one thing. Even before you solve this question, I want to see how you are able to apply the ray diagram concept. So there is a concave mirror. You think the answer for image distance will be negative or positive? Don't look at the textbook or anything. Try to guess. Will the image distance be positive or negative? Look at the data from the question. So I'll give you an idea to think. Focal length is 15 centimeter. So what is the radius of curvature?
30.
30. Where is the object placed?
25.
So 25 falls between
30 and 15.
center of
C and F.
curvature falls between C and F. Between C and F, if an object is placed, where is the image formed?
Beyond C.
Beyond C. So you're going to have the V value negative or positive?
Negative.
Yes. If you
It
don't
is.
get a value in your final answer, then you have gone wrong somewhere. Okay. Because you know the concept behind it. V should come out as negative. Now I have another question. Will the value of magnification in this case be greater than 1 or less than 1 even before you solve?
Greater than 1.
It will be greater than 1. Yes, it will be greater than 1 because the image is formed beyond C. Beyond C means image will be magnified. Right? Similarly, magnification value, will it be positive or negative? In this case, magnification value will be negative or positive. In the previous case, I told you, magnification value is positive, it is always a virtual image. So in this case, is it forming real or virtual image?
Real image, sir.
Sorry, I didn't get you. It forms a
Real
Real
image.
image.
real image. So magnification should be
Negative.
it's be negative. Okay. These are all the guesses. I'm not talking about the values. Okay, these are all the guesses you need to have before. These are all the checkpoints rather than guess. These are all the checkpoints. You need to ensure that you're attaining these values. If not, you're wrong with something else. Okay, so V value is negative. V is minus 37.5. And obviously, beyond Siemens, it should be greater than how much?
1.
Lemma,
Greater than 1.
the image distance should be greater than 30. Correct? Then a focal length is 15. Center of curvature is at a distance of 30. Beyond Siemens, it should be greater than 30. Look at the answer. Your answer is greater than 30, 37.5. Correct?
Yes, sir.
Okay, that is one thing. So that is where the image is obtained. So magnification, what is the formula? It is minus V by U. That is equal to height of the image divided by height of the object. Remember, minus V by U should be remembered. Height of the image by height of the object. There is no sign in the formula. You have to apply the sign only after you introduce the values. So minus is in the formula. V is how much? Minus 37.5 divided by U is how much? 25 with a negative sign, minus 25 is equal to height of the image. We don't know. So you should not apply sign convention. Height of the object is 4 centimeter. So when you try to calculate, height of the image will come out to be minus 6 centimeter. What does this minus indicate?
That it is
It is an
inverted.
invert real image.
It is a real image and it is an inverted image. It is an inverted image, and if you look at the size, 6 centimeter is definitely greater than 4 centimeter, and it is an enlarged image, enlarged or magnified. So guys, I just want to ask one question. I'm not concerned about this problem. I'm only concerned about, are you people able to think like how you are supposed to visualize a problem? Am I clear with that?
Yes, sir.
I hope everybody made a note of all the important points that I told. Right? Now, let's do the other problem. Just give me a minute. I'm getting a call. Just a minute. We'll proceed. Next is, find the focal length of a convex mirror whose radius of curvature is 32 centimeter. Answer. 16 centimeter, right? It's very simple. Next, second, there is a concave mirror which produces 3 times magnified real image of an object placed at 10 centimeter in front of it. Where is the image located? It's just one step. So V is how much? Magnification is, they told, it forms a real image. So for a real image, magnification obviously is going to be negative. So minus V by U is the formula. So this is equal to minus 3. Why did I write minus 3, guys?
Because it's a real image.
Yes. So minus and minus will get cancelled. V is how much? That's what we need to find. U is how much? Minus 10 is equal to 3. So V is equal to minus 30 centimeter. If suppose I want to twist this question, what should be the least value of focal length in this question? Okay, I'll put it like this. What should be the value of radius of curvature? You cannot find the value, but you can find a range. So V is minus 30 centimeter. So object is placed at 10 centimeter. Where will you get an enlarged image? If you recollect all the ray diagrams from concave mirror, where all do you have enlarged image? Enlarged real image.
Between focus and center of curvature and at
So
the focus.
At the focus, right? But here, see, if they place it at the focus, what is the magnification? If they place it at the focus, magnification is how much?
Infinity.
It is infinite. If the object is placed at infinity, the magnification is 0. Okay. So if you want, you can make a note of all these points. Here, what is the magnification? Is it less than 1 or greater than 1 in B? When the object is placed beyond C, magnification is less than 1. So here magnification is equal to 1. Here magnification is greater than 1. Here also magnification is greater than 1. So what is the difference between these 2 points? Between D and F?
One forms a real and one forms a virtual.
One forms a virtual. That is why if you observe the question, they are very particular. They told it forms a real image. So the object should definitely have been placed between C and F. Okay. So what should be the value? What should be the least value of F that is possible?
More than 10.
Should be less than 10. Because according to the question, this is 10 centimeter. So F should be less than 10. See, they will not ask these kind of questions. It is just to improve your thought process. Okay. So this is why you got the answer here as 30. Are you able to visualize it? Clear?
Yes.
Good. So that is all about reflection and mirror. If you are clear with this, I will proceed to the next topic. Shall I proceed? Next. So we have seen what is the phenomenon of reflection of light. Now my question is, what about refraction of light? So what do you mean by refraction? Anybody? So what do you mean by refraction of light?
Bending
It's a
of light
range
when
of
it
path.
passes from
Sorry?
one medium to the other.
What
Bending
happens?
of light when it passes to one medium to the other.
Oh, so it is like bending of light. It is a phenomenon where the light It has the tendency to bend. So bending of light when it travels from one medium to another. Correct? So you're using the word medium, right? What does that medium indicate? So what are the types of media that you know? Medium is singular, media is plural. So what are the two types of media that we know?
Rare and dense.
Rarer and denser.
Okay, now the other question is rarer and denser. Now the question is, how do you classify a given medium as rarer and given medium as denser? How will you know? So what are the criteria that is used to call a particular medium as a rarer or the particular medium as denser? Anybody? Okay.
When
So what
light
are the
passes from rarer to denser medium, it moves towards the normal, and when light passes from denser to rarer, it moves upward.
that's right. But not every time it is like, see, I'll put another question in reverse. How do you know that it will bend towards? Who told you? We don't know, right? I'm not sure that, somebody told me that it moves from rarer to denser, it will bend towards the normal. Every time I cannot have a diagram to find out whether it is a rarer medium or denser medium. If I give you a numerical value, you should be able to say whether it is rarer or denser medium. How are you going to do it? Anybody?
Depending on the refractive index, if it's more
That's right. That's right. That's right. If the refractive index is more, then it is a
denser medium.
then it is a denser medium. If the refractive index is less, then it is a rarer medium. But I have another question. Till now, I didn't use the word refractive index. So what are the parameters that we can think of? Now I'll put a question like this. Let's try to connect the dots. So if I talk about the speed of light, okay, what is the maximum speed of light that is possible? Yes.
3 into 10 power.
3 into 10 power 8 meters per second or 3 into 10 power 10 centimeters per second. So this is the maximum speed. You cannot attain a value greater than this. Right? Now I have a question. If I have a boundary which is separating two media, for example, let me call this as air medium, let me call this as water medium. Now, in air medium, I know the speed is 3 into 10 power 8 meter per second. Do you think the speed of light in water is also going to be a value of this one? Is it
No.
going to be of the same? Is it going to be less or more?
More.
You mean to say in water, the speed of light is more. I told you one important point. The maximum speed that you can generate is 3 into 10 power 8. That is already present in air medium. So what should happen? As it is entering water, its speed will be less than 3 into 10 power 8 meter per second. Please make a note of this point. Okay. Now I'm going to define an important parameter. Listen to this carefully. Okay. So rarer medium or denser medium is only a comparative study. What do you mean by comparative study? I can call a medium as a rarer or denser only if I have minimum of two values in my hand. For example, if I give you the value of speed of light is 2.2 into 10 power 8 meter per second, you come and tell me whether it is a rarer medium or denser medium. I will not be able to conclude because I
We
don't
only
know
have one value.
one value. You are asking me to compare this value with whom? So my question is invalid. Right? So for my question to become valid, rarer or denser, I minimum need two media. More than that, you can have any number. Suppose I gave a value as 2.2 and I'm giving another value as 2.8 into 10 power 8 meters per second. Now you conclude which medium is rarer and which one is denser. Will you be able to do that?
Yes.
So which one is rarer?
2.2 into 10 power 8 is rare.
2.2 into 10 power 8 is rarer.
No.
2.8 into
2.8 is rare.
2.8 into 10 power 8 is rarer. So from this, since you people told me a value, from this, can you frame a definition to a rarer medium?
In rarer medium, the light travels fastly compared to the denser medium.
Perfect. So on a comparative basis, if you have a medium in which the light travels faster compared to the other medium, then the medium in which the light travels faster is called as the rarer medium, and the other one is called as the denser medium. Right? So from here you can conclude that rarer medium will have a greater speed compared to a denser medium. Please make a note of this point. From this, I will relate why refractive index comes. Please make a note of this point. So next time, if somebody asks you what is the rarer medium, don't say this normal thing at all. You have to use the word speed of light. That is where the definition comes from. Okay. Now comes another point. If this is the case, so if this is a phenomenon that can be observed just like reflection, there were certain laws for reflection. Similarly, are there any laws for refraction as well?
Yes.
So what are they? See, the proof for all these things you learn in your 12th standard. Now, if you know the statement, that is enough. First, incident ray, refracted ray, and normal all lie in the same plane. Am I right? Now I have another question. The second one is the most
Sir,
important. Tell me.
in the first point, when they say that they lie on the same plane, they mean like on the same side of a Cartesian plane, right?
Yes. Same plane means xy plane means xy plane.
Oh, doesn't
See,
this include the z-axis? Because
no, it
we
will not
need
include
ED
z.
of
It will not include z-axis. It will not include. Oh, for example, to clear your doubt, I will switch on the video and show. Just a minute. My device is undergoing charge. Just a minute. Am I visible? See, you take a paper. You are able to see the grid, right? So, if I take this line as the boundary, okay? If this is how the incident ray is, now I'm putting a question. This is x-axis, this is y-axis, okay? And towards you is z-axis. Okay, I'm repeating it. The base is x-axis, the vertical is y-axis, and towards you is the z-axis. Now the question is, this particular ray is in which plane? This is incident ray.
could you repeat that, sir?
It is in which plane? This is x-axis, this is y-axis. So what is the name of this plane?
Cartesian plane.
Cartesian plane is right. The Cartesian plane will have a name. X-axis and y-axis together is called as xy plane. Okay, if you don't know that, try to understand. Try to learn it now. X-axis and y-axis put together, that rectangle falls under xy plane. Okay, if it is y-axis and z-axis, if I talk about my hand like this, then my hand is in which plane? X-axis and z-axis. Hand is in
Exact plane.
very good. It is an exact plane. Similarly, y-axis, z-axis. It is like this.
YZ plane.
It is called YZ plane. Now, to answer your question, that all lie in the same plane. Now, visualize it. Incident rays in which plane?
XY plane.
XY plane. Okay. The refracted ray should also be in the XY plane. It should be like this. Means if I extend it like this, if I open and extend it like this is x-axis, negative y-axis, positive y-axis. Okay. Incident ray is in xy plane. Then the refracted ray should also be in the xy plane. That is what I mean. It should not be like this. Means incident ray cannot be like this and refracted ray cannot be like this.
Okay.
It's like
Okay.
you're able to understand. So that is
Yes,
what
sir.
they mean. Lie in the same plane.
Okay. Thank you.
Yeah. So who asked it?
Sri Lekha, sir.
Okay. They're in the same plane. Next is sine of what? The ratio of sine of angle of incidence to the sine of angle of refraction is always a constant. What is the name of that constant?
Refractive index.
That's what we call it as refractive index, and the constant is what we call it as refractive index, represented by symbol mu. Okay. Now comes another question. How do you define refractive index as? Okay, sorry. So that's called as refractive index. So the ratio of sine of I by sine of R is mu. That's what we call it as refractive index, right? So this is the mathematical expression for an other law. What is the name of this law? It's called
Science.
Snell's law, right? So now we came across a new term which is called as refractive index. Now I have to define it. How do we define it? So what is the refractive index? It is the ratio of whom? The ratio of speed of light in dash to the speed of light in dash. Fill in the blanks.
Vacuum and the medium, which is
So speed of the light in vacuum to the speed of light in given medium. Very good. So mu is equal to C divided by V, where C is how much? By default, it is 3 into 10 power 8 meters per second. What does V stand for? It stands for the speed of the light in a given medium. Right? So from this, I have an important conclusion to be drawn, that the refractive index is inversely proportional to V. What do we mean by that? So I'm able to conclude it because C is always a constant. So from this, we can say the refractive index is inversely proportional to the speed of the light in a given medium. So what do I mean by saying inversely proportional?
more the speed, less the
More is the speed, lesser will be the refractive
refractive
index.
index.
Now, I have speed of light in rarer medium, speed of light in denser medium. Which side should I put the greater than symbol?
Towards the rarer medium, the speed is faster.
So there's the right. Now, refractive index of rarer medium, refractive index of denser medium. Which side should I put the greater than symbol?
Towards the denser medium.
Now, did you understand why this is actually coming?
Yes.
Good. This is the reason why we say the refractive index of denser medium is greater than the refractive index of the rarer medium. Clear? Okay. Shall I proceed? So another way to look at these Snell's laws, if there is a boundary like this, what is the name of this ray? If I say this is medium 1 with refractive index mu1, this is medium 2 with refractive index mu2, mu1 by mu2. Tell me, sine of what is the incident ray? So this will be the angle of incidence. If this boundary was not there, the ray would have traveled in a straight line path like this. Okay. Now, if I draw a ray like this, I'm still not sure of which one is rarer, which one is denser. Don't get into confusion. Then this is called as the refracted ray. Then this angle is called as the angle of refraction. The other way to observe Snell's law is sin I by sin R is equal to mu2 divided by mu1. Please make a note of this point as well. Sin I by sin R is equal to mu2 divided by mu1. Does this make sense? Right? Shall I proceed? Okay. In your textbook, they have given it as N21 and N12. What does this mean?
It's going from medium 2 to medium 1.
So it is called as refractive index of medium 2 with respect to medium 1. This is actually called as, they don't use this word, but it is actually called as relative refractive index. Okay, it's called as relative refractive index. Similarly, N12 is given as refractive index of the first medium with respect to second. That is also called as relative refractive index. It is, so N21 is V1 by V2, N12 is V2 by V1. Okay, and Nm is generally called as the absolute refractive index. So this is another important point. In physics, wherever you see the word absolute, no, absolute means they are doing a comparison with a known value. For example, speed of light in air is a known value. So when they write the definition of refractive index in terms of known value, they call it as absolute. If they write it in terms of unknown values, they call it as relative. Okay. Now, let's do some questions. So a ray of light traveling in air enter, or what do you mean by obliquely? Slanting into water. Does the light ray bend towards the normal or away from the normal? Why? Okay.
Towards the normal.
So how do you know that?
Because when it
Travel.
travels from a rarer to denser medium,
When the ray
it goes
travels from
towards.
rarer to denser medium, it bends towards the normal. And the answer why they are asking why? Because air is rarer medium and water is denser medium. Next. Light enters from air to glass having refractive index of 1.50. What is the speed of light in glass? The speed of light in vacuum is 3 into 10 power 8. So they have given refractive index of glass, which is how much? 1.50. What is the definition of refractive index? C divided by V. So V is equal to C divided by 1.5. C is how much? 3 into 10 power 8. This is 1.5. Answer is 2 into 10 power 8 meter per second. So if you observe, as the light is entering water, you can observe that the speed is decreasing. Okay. Third, from the table 10.3, find the medium which has the highest optical density in the retina. So which is the medium which has highest optical? Diamond, because it is having a greater value of refractive index. So also find the medium with the lowest optical density, it is air medium. Okay. Next is, you are given kerosene, turpentine and water. In which of these three does the light travel fastest? Kerosene, turpentine and water. So water 1.33, kerosene
Water.
is 1. So
Water,
obviously
sir.
water, because its refractive index is less. It is rarer medium. Next. The refractive index of diamond is 2.42. What is the meaning of it? So you can just say it's a denser medium. It is an optically denser medium. Or you can say the speed of light in this medium is twice. Is half of the speed of the light in air medium. You can say like that also. So mu is 2.42. So 2.42 is equal to 3 into 10 power 8 meter per second divided by V. So V will be how much? It is so speed of the light in the medium is 1 by 2.42 times the speed of the light in air medium. You can state like that also. Okay. So I hope it is clear. Next, do you guys know how the refraction through a glass slab takes place? Did you guys do this activity in school?
We didn't do the activity, but we don't know how it works.
You know how it works, right? Okay. So I will show you a mathematical expression for it. If I take this as a glass slab, okay. Now I have an incident ray. So at the point of instance, by default, you should draw a normal. This would be the angle of incidence. So let me call this as air medium. This is glass medium, and this is again air medium. Okay. Now, what would have happened if the first boundary was not there? The light would have continued to travel in its straight line path. It would have continued to travel like this. Right. Now, since the ray is traveling from rarer to denser medium, it will bend towards the normal. Let me call this as R. Okay. So it is hitting the second interface. Right. So let me call this angle as R2. Had this boundary not been there, it would have traveled in a straight line path. Right. Now what will happen? Since it is traveling from denser to rarer medium, it will bend
Away from the
it will bend away from the normal in such a way that what is the important phenomenon that you can observe here?
incident ray is parallel to the emergent ray.
This is what is emergent ray. So emergent ray is parallel to the extended incident ray. Okay? This is what you can observe. Now the next question is, what is the distance between these two rays called as? Anybody? It's called lateral displacement. Okay, you can make a note of that point. It's called lateral displacement. Next is, this angle is called as the angle of emergence. Okay. Now I have a question. How did you people know that the emergent ray and the incident ray are parallel to each other? Is this an experimental conclusion or can you prove it theoretically also?
So parallel lines.
Parallel? Okay, I will do and show. If I call the refractive index of outside medium as mu1 and glass medium as mu2, the refractive index of the other outside medium is also mu1 because both sides it is air. Okay, I will just prove and show. This is not from exam point of view, but to again make you understand how you can think. Okay, so what does Snell's law state? Sin I by sin R is equal to mu2 divided by mu1. Here, important point is mu2 is the refractive index of the medium on the other side. So mu2 is the refractive index of the medium where the ray is getting refracted, and mu1 is the refractive index of the medium where the ray is incident. Okay, so tell me, sin I divided by, if I apply Snell's law at boundary 1, how should I apply the formula? Sin I divided by sin, what change should I write? Sin R1, correct? Is equal to mu2 divided by mu1. Guys, accepted?
Yes, sir.
first. Similarly, how do I apply Snell's law at this boundary? Let me see whether you guys understood or not. This is at boundary 1. At 2, how do I apply Snell's law? Sine divided by
R2
sine. Mu divided by mu. Bullet. Sine
sin
R2.
R2 by sin E
Very good. Is equal to
is equal to 1 by 2.
mu1 by mu2. Very good.
Yeah.
2. Now the relation between R1 and R2. Think and tell me. This is a normal. This is a normal. This normal and this normal will be
Parallel.
parallel to each other. So what will be the relation between R1 and R2?
Oh no, they'll be
angles.
equal.
Alternate
interior angle.
Alternate angle. So R1 will be equal to R2. If I take the first expression and multiply it with the second expression, can I write it like this? Sin I divided by sin R1 into sin R2 divided by sin E is equal to mu2 by mu1 into mu1 by mu2. Can I write it like this? Now see what is going to happen. mu1 will get cancelled, mu2 will get cancelled. Right side will be 1. So R1 is equal to R2 means can I write sin R1 is equal to sin R2?
Yes, sir.
So sin R1 and sin R2 will get cancelled. So sin I divided by sin E is equal to 1, which implies sin I is equal to sin E. From this, what can you conclude? I is equal to E. If I is supposed to be equal to E, then what should happen? Then
The extent
emergent,
of bending would be equal.
the emergent ray should be parallel to the incident. No other option. So this is a theoretical proof, though it is not from the exam point of view. Don't get confused. I've just explained it so that you're able to understand how to apply Snell's law. Clear?
Yes, sir.
So that's it from my side for today. I have another class, so we'll wind up with this. If you have any doubts, you can ask by sending a message to me, or you can ask it for tomorrow's class. So I'll see you all tomorrow. Okay. See you guys.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.